Alright, hey guys, I'm going to do some problems on the Homework 9 recommended problems because I know this is still a difficult topic for a lot of us. Yeah, I don't feel like doing all of them. I mean, like, if you really want me to, email me, but in the meantime, I'm just going to do these ones. So, let's go ahead and do this problem first. So just to let you know, this is Homework 9 recommended. So this is not actual the homework. It was like practice homework in case you wanted extra problems. But I thought it might help in case you were still stuck on why or how to do the Homework 9 problems. So let's do this one. It says express the area of an equilateral triangle as a function of a side x. All right, so if you've watched my kind of like lecture-ish video, you know that if we want it as a function of a side x, that means we want the area to be something, 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 something with x's in them, and we want the only variables to be x. So let's go ahead and just draw what this looks like. Let me erase this for a second. So I've got the, let's see, an equilateral triangle. That just means all of the sides, lat means side, all of the sides are equal. So I'm going to draw this, and boom, that's like pretty close to an equilateral triangle as a function of a side x. So one of the sides is x. Well, guess what? It's equilateral, so that means all of the sides are x. So I'm just going to put x like that. And now we want to find the area in terms of x. Well, usually, how do we write the area of a triangle? The area of a triangle is the base times the height divided by 2. So I'm just going to go ahead and draw the height right here. All right. So I could really rewrite this as A is equal to the base, which is x, times the height over 2. Uh-oh. Because we got the area, but we don't have it in terms of just x's. Look, because we have this extra variable, this h there. We don't want that there. So how can we rewrite that with just x's in order to get a function of, to write it as a function of just one variable, of just x? Well, let's do this. Okay. So basically what that means is we want to rewrite h using x's. Well, I know that the height of this equilateral triangle is going to split my base into 2. So this side of it is x over 2. It's half of x, and this is also half of x. So now look at here. This pink part is kind of like a right triangle. And what do we know about right triangles in heights? Or in like side lengths? Pythagorean theorem. Nice job. Sorry if you didn't know it, but I'm just whatever. All right, so Pythagorean theorem says a squared plus b squared equals c squared. So this is x over 2 squared plus h squared is equal to our hypotenuse squared. If we solve for h, let's see, I'm going to subtract x over 2 squared on both sides. And I'm going to get h squared is equal to x squared minus x over 2 squared. And x over 2 squared is the same thing as x squared over 2 squared, which is 4. And this is the same as, let's see, I could rewrite this as 4x squared over 4 minus x squared over 4. So this is 3x squared over 4. Now, I know that was just like a lot of like bleh math, but remember, so we have h squared is equal to this, which means if I take the square root of both sides, I get h is equal to positive or negative. Well, the square root of this would be the square root of the top, which is x root 3, if you're wondering, because I get the square root of 3x squared. This taken out is just x, because the square root of x squared is x, and then we have that square root 3 left over. And then divided by the square root of 4, which is 2. But we don't have to worry about the negative because h is a height, which means it's a length, and lengths are always positive. So now I know h is equal to x cubed, or x times the square root of 3 divided by 2. Now why did I do that? Because now I can rewrite this as this. All I did was replace the h with x times square root of 3 over 2. And now if I just simplify this a little, I'll get a is equal to x squared root 3 all over 4. All I did was just simplify. These are the exact same thing, and you can double check it yourself. I know that's super messy. Let's double check and see if my answer is right. Hey, my answer is right. All right, sweet. So I did that part. Cool. So what did I do? I just took an equilateral triangle. I wrote it how like I wrote my function for an area like I'm used to writing it, but then I replaced anything that didn't have x's with something that did have x's. And I found out that h was equal to this using the Pythagorean theorem. Cool. Okay, I guess I'm going to split this into parts because uploading like a 15-minute video is just honestly the worst. Okay.